Solving equations with algebraic fractions with adamonlinetutoring. Here's the beginner question, one of the easier questions that you're likely to be examined on. Algebraic fractions are fractions where the numerator, denominator, or both contain algebraic expressions involving variables like x or y. Some more simple examples can include things such as x over 2, x plus 1 over 5, 2 over 5 minus x, or something a little bit trickier which has algebraic expressions at the top, so x plus 2, and algebraic expressions at the bottom, such as x plus 3. Solving equations with algebraic fractions means finding the value or values of the variable that make the equation true. So in the case of this question, it would be finding values for x that when substituted, the left-hand side would equal the right-hand side, which is 1. To solve these, the goal is to eliminate the fractions to simplify the equation into a form you can solve, like a linear or quadratic equation. Firstly, we'll want to simplify the left-hand side into a single fraction instead of partial fractions. We'll be able to do this exactly the same as we do with numerical fractions, where we find common denominators. Typically, we would aim to find the lowest common denominator. That's quite difficult to identify when you have algebraic expressions, so instead we just find common denominators, and we can do that by multiplying 5 minus x, which is the expression at the bottom of one of them, by x plus 7, which is the expression at the bottom of the other. By multiplying them, we know that this will definitely provide a common denominator. So writing as a single fraction with my common denominator 5 minus x, x plus 7, since this fraction on the left has been multiplied by x plus 7 at the bottom, I'll need to keep it as an equivalent fraction by multiplying by x plus 7 at the top for the numerator, giving me 2 lots of x plus 7. This is being added, and again x plus 7 has been multiplied by 5 minus x. So to keep this as an equivalent fraction, I'll also need to multiply the top by 5 minus x. So we'd be adding 3 lots of 5 minus x, and this is equal to 1 on the right hand side of the equation. Once written as a single fraction, we can multiply both sides of the equation by the common denominator of all the fractions involved. This clears the denominators, leaving us with a much simpler equation to solve. So multiplying through by the denominator will leave me with 2 lots of x plus 7 plus 3 lots of 5 minus x on the left hand side, and 1 multiplied by 5 minus x, x plus 7 on the right hand side of the equation. As you can see, the denominators have been eliminated, and I can now focus on expanding and simplifying each side of the equation. 2 lots of x plus 7 is 2x plus 14, and then adding 3 lots of 5 minus x will be plus 15 minus 3x. Multiplying by 1 will keep this the same, so I can just focus on expanding these double brackets. 5 multiplied by x is 5x. 5 multiplied by 7 is 35. Negative x multiplied by x, negative x squared. And negative x multiplied by 7, negative 7x. Simplify by collecting like terms. 14 plus 15 is 29. And 2x take away 3x is negative 1x, or negative x. And this is equal to negative x squared on the right hand side. 5x minus 7x is negative 2x, along with positive 35. We have a quadratic equation, which if we make equal to 0, we should be able to solve. It will be easier if the negative x squared term is made positive. So I'm going to add x squared to both sides, giving me positive x squared on the left hand side. I'll also add 2x to both sides. Negative 1x plus 2x is positive 1x. And then I will subtract 35 from both sides. 29 subtract 35 is negative 6. And this is now equal to 0 on the right hand side. Once my quadratic equation is made equal to 0, I should then be able to solve to find solutions for x. Since it's a non-calculator question, it's highly likely that this quadratic will factorize. If on a calculator paper, it may be more likely that you will have to use the quadratic formula at this point, looking for numbers that multiply to give me negative 6, add to give me positive 1, provides me with my double brackets of x plus 3 and x minus 2. If x plus 3 is equal to 0, then one of my solutions for x would be -3, and if x minus 2 was equal to 0, then my other solution for x would be +2. You can check your solutions for x by substituting them back into the original equation to see if the equation holds true for the left-hand side equal to the right-hand side. On to the intermediate question with an increase in difficulty. This time we have algebraic expressions as denominators of x plus 1 and 3x minus 2, multiplying them to find a common denominator so that we can represent these partial fractions as a single fraction. Since the x plus 1 has been multiplied by 3x minus 2, I'll also need to multiply the top by 3x minus 2 to keep it as an equivalent fraction. 7 lots of 3x minus 2. This time we have a subtraction separating the fractions, and likewise 3x minus 2 has been multiplied by x plus 1, so I'll also need to multiply the top, giving me 4 lots of x plus 1, and this is equal to the right hand side of the equation 1. Multiply through by the denominator, giving me 7 lots of 3x minus 2 minus 4 lots of x plus 1, which is now equal to 1 multiplied by the denominator. Expand each of the brackets, 21x minus 14, -4x take away 4, and multiplying these double brackets by 1 will keep them the same, so just focus on expanding the double brackets. 3x squared plus 3x minus 2x minus 2, simplify the left hand side, 21x take away 4x is 17x, and -14 take away 4 is -18. This will be equal to 3x squared plus 1x minus 2. We have a quadratic equation. Make it equal to 0 so we can solve. Since we ideally want to keep the x squared term positive, we can keep these terms on the right hand side whilst subtracting 17x and adding 18 to both sides to make equal to 0. That will leave me with 0 on the left hand side, 3x squared on the right hand side. 1x take away 17x will give me -16x, and -2 plus 18 is +16. We have a quadratic equation, non-calculator, so likely to factorize, but the coefficient of x squared is greater than 1. The AC method can be used to help us factorize. Multiplying 3 by 16 gives me 48, and factors of 48 which add to give me -16 is -4 and -12. Separate the -16x term into -4x and -12x, and then factorize the left hand side and the right hand side into single brackets. The left hand side would be x bracket 3x minus 4, and the right hand side, the bracket, if done correctly, should be the same, so we can use this to help us factorize, meaning I would need to multiply 3x and -4 by -4 to give me the -12x and the +16 that I have above. So the factorized quadratic will have one bracket as 3x plus 4, as 3x minus 4, and the other bracket will be made up of the x and the -4 that we have as factors for each of the single brackets. Therefore 0 is equal to 3x minus 4 bracket x minus 4. If 3x minus 4 is equal to 0, then x would be equal to +4 over 3. And if x minus 4 was equal to 0, then x would be equal to +4, meaning my solutions for x, which hold the equation true, would be when x is equal to 4 over 3 and x is equal to 4. On to the advanced question, one of the trickier questions that you're likely to be examined on. Given that x plus 9 to 5x minus 1 is equal to x plus 7 to 2x minus 3, find the possible values for x. At first glance, not immediately obvious to be an algebraic fractions question, as the algebraic expressions are hidden within the format of ratios. We can use the proportionality between ratios to help set up an algebraic fractional equation. We can use an example of some numerical ratios to help us understand how to form the equations. If I tell you the ratio 4 to 2 is equal to 2 to 1, we know this to be true since we can just divide both parts by 2 if we're converting from here to here, or multiplying both parts by 2 if we're working from here to here. Then representing these as fractions, 4 over 2 is also equal to 2 over 1. which again we know holds true using what we know about equivalent fractions. It doesn't matter whether you put the left-hand side of the ratio as the numerator, or if we did it as the denominator, such as 2 over 4 would still be equal to 1 over 2. We can use this same logic since we're told that x plus 9 to 5x minus 1 is equal to x plus 7 to 2x minus 3. So writing the left-hand side as an algebraic fraction, putting x plus 9 as the numerator and 5x minus 1 as the denominator means this would be equal to x plus 7 as the numerator and 2x minus 3 as the denominator. Slightly different to the equations where we had to add or subtract to find single fraction. We already have a single fraction on the left-hand side and the right-hand side, so we just need to multiply through by both of the denominators to eliminate the equation written with denominators. So starting by multiplying both sides by 5x minus 1 will leave me with x plus 9 on the left-hand side, and then x plus 7, which needs to be multiplied by 5x minus 1. Since I'm multiplying more than one term by a bracket, I would need to introduce a bracket around the x plus 7 as well. And this is currently still being divided by 2x minus 3. Now I can multiply through by 2x minus 3 to eliminate this denominator. This would give me x plus 9 multiplied by 2x minus 3 on the left-hand side, which is equal to x plus 7 bracket 5x minus 1 on the right-hand side. We could have done both of these two steps at the same time, cross-multiplying 5x minus 1 over to the right-hand side and 2x minus 3 over to the left-hand side to eliminate that line of working out and to save on time in the exam. Now I have a more simple equation which can be solved. Firstly, by expanding the double brackets on each side of the equation. On the left-hand side, expanding the double brackets would give me 2x squared plus 18x minus 3x minus 27, which is equal to the double brackets on the right hand side, which expand to give me 5x squared plus 35x minus 1x minus 7. Collecting like terms, the 2x squared and the negatives 27 will remain the same, but 18x minus 3x will simplify to give me positive 15x. And on the right hand side, 5x squared and negative 7 will stay the same, but 35x minus 1x is positive 34x. Equating equal to 0 will allow me to solve. Subtracting 5x squared from both sides will leave me with a negative x squared term on the left hand side. So I'm going to start by subtracting 2x squared from both sides, subtracting 15x and adding 27. This will leave me with 0 on the left hand side. 5x squared take away 2x squared is 3x squared. 34x take away 15x is 19x. And negative 7 plus 27 will give me positive 20. Again, I have a quadratic equation on a non-calculator paper, so it's likely to factorize. And since the coefficient of x squared is greater than 1, I can use the AC method to help me do this. A multiplied by c is positive 60. And factors of positive 60 that add to give me 19 will be positive 15 and positive 4. Split the 19x term into positive 15x and positive 4x and factorize each side into single brackets. The left hand side, 3x bracket x plus 5. And if done correctly, this bracket will remain the same, helping me to factorize, which must be 4 on the outside. So the double brackets will be made up of x plus 5 and 3x plus 4. Therefore 0 is equal to x plus 5 bracket 3x plus 4. And if x plus 5 equals 0, then a solution for x would be negative 5. And if 3x plus 4 equals 0, then another solution for x will be negative 4 over 3. Therefore the equation holds true when x is equal to negative 5 and x is equal to negative 4 over 3. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.